Okay, my friends, I can't wait to get into this one. What are gravitational waves? This goes back to 2015, but I just saw another post on this a minute ago. Now, these are what they're considering to be gravity waves. Artist's impression. Who wants to bet against Einstein? You? You? What about you? Well, what about me? I will take that bet. Fraser. Okay, don't forget, this is not my picture. That is from Fraser Cain. What do you see here? You see that black one? You see that white one? You see all of these fields around them? You see this one? The black one? The black one looks like it's headed towards the white one. The white one has similar fields surrounding in every direction because it pushes everything away, except the black one is extremely attractive to the white. Now, on Earth, the Earth sucks in all the white particles. Electricity, bzzz, right to ground. Lightning, bzzz, right to ground. Everything you drop goes towards the Earth because it's saturated with white particles. The Earth is saturated with dark particles. Anywhere that there's gravity, there is darkness. This is nothing more than what I am about to show you that happens in space. Don't forget the black and the white. They're dipoles. Everything's a dipole, even in space. It's amazing, but it's true. All right, I have a lot to show you, and we are going to go through the books, and we're going to go through all of the theory. And long ago, you see this? I did all this stuff many, many years ago, and I still do it to today. So I'm not just guessing about the things I'm saying. I at least have some supporting evidence. And this was not my picture. This was from Fraser Cain, and here is our pictures of space. And that's all this is. I don't know how Dylan Carpenter did this. He's got a phone, and the phone, he just took these pictures. I don't know what setting he had it on, but I can tell you what, those are magnetic fields, and these are dipoles, and this is the moon, and the moon has a blue field around it this way because apparently it's heading this way and crushing the particles, turning them into the blue shifted. Not red shifted, it's forcing, crushing particles, making them compact and turn blue. And can I show that actually happen in our experiments? Yes, I can. And here it is right here. That's the compaction of a red particle turning into a blue particle. These are Higgs fields from light. We did some serious research on this light. Rod Warren did some absolutely amazing stuff. And this is it. And his nephew Dylan did the, see, this is Dylan's stuff. He did this one, and he did this one here is another one he did. And I think that's Venus because it's got two fields. You see the second field? Venus is moving forward and spinning backwards. So I think it might have two fields, and this might be Venus. I don't know. I have no idea. All I do is get these pictures a lot of times. Now, I have studied them very, very well, and I understand the Dirac neutrinos, which is, they're calling matter and antimatter. That's fine. Call it whatever you want. They also call it muons and electron neutrinos, which we picked up in our light experiments, and they are glued together. The black sucks the white to it. They suck it up. Right here, look, see here? The black sucks the white into it. The white has separated from the black in this because of this interaction. And they come back together as the original particles which were glued together. And they call them gluons. Two gluons make a photon. That's a photon. And I have all of this stuff in every little detail. The green ones and the red ones are identical. See the red, very low energy. You see the green, very high energy. You see the difference between the two of them coming through the slit at the same time? This one just goes nowhere. This one reconcusses way out here. Same particles, well, it's two lasers going through the same venturi at the same time. All right, so the red and the green and blue, they're all an identical particle. It's just a faster spin, and light does spin. Yes, absolutely it spins. And here it is spinning right here. All right, this single slit, it's not the double slit. And the reason these things are bounced apart here like this is because that's a separation pattern. The whites don't want to be next to the whites. They push them apart. That's why you end up with these elegant little stripes. It's because the particles are going through the slits, just like this. The slit is here. The particle is going this way. So sometimes it goes that way, sometimes it goes this way. You see it? Here's the particle coming down. Right hand spin, zoom, it goes through this way. Sometimes it goes right down through the center. Sometimes it comes way off over this way. Sometimes it comes through the center, sometimes it comes off this way. That's why it's a spinning particle, it's not flapping. This is a single slit. So again, we got a lot to talk about. And or every one of these pictures I'm going to go through and we're going to explain it. And this, my friends, right here is a gravity wave. The black is pushing the white. That's anti-gravity. That's literally anti-gravity. Gravity should be the black having the white suck to it. Like the earth sucks particles down. Lightning, static, electricity, weight, everything goes right to ground earth, which is black. Now this time the black is pushing it away. This is nothing more than an atomic bomb. And I can show you this happening in an atomic bomb. We did it on a subatomic level, inside of light, basically. This is two particles. The light is just, it separates. I never thought that was possible. When I saw this in space, the Russians did this in space, and I said, whoa, this is not right. As they did. When they saw it, they couldn't believe it. See, during the experiment, they contacted Earth guys who couldn't believe it either. A guy from Max Planck locked himself in his office for 3 weeks, they said, because he just freaked out. They had expected to see him sort of separated apart in semi-equidistant areas, to like you push me, I push you, and we'll stay apart. No, it's formed that black hole. And as far as I'm concerned, that was the first black hole ever, and that was 2015. Or maybe even earlier now. It was a long time ago. And so is our research. It's been going on for years and years. Anyway, we got a lot to talk about. We got a lot to talk about. Higgs, these are the Higgs fields that CERN is talking about, and Fermilab and all them. But they're using protons, so they explode like gigantic balls of debris. We're using light, so we don't have that problem. When we put them through the venturi and we collide and we get this, coming through the venturi with one little tiny slit here, and it's a funnel like here, and it's through that slit. And once the black can't get through, it just can't get through. It's too big. The black, you see them the same size everywhere. They cannot get through, and they're a fixed size, exactly what Don Lincoln at Fermilab says in this right here. This is the fixed particle. That's exactly what he calls it, fixed, never changes. That one gets big and small and big and small, and there they are right there. And here's the fixed one. You see? This is just a color enhanced of this. And this is getting glowy, and this one's getting dim because it's going that way. This one's concussing, this one is not concussing, the black is shielding it. And when you go through the Cherenkov radiation, which is you come into a new medium, which this is nothing more than a new medium. They're high energy. This just means high energy. High energy, V energy, U energy, V, voltage, high voltage. They're coming through the black and the white together. The black goes on its way, never changes. You see it? No change. The white, it turns into electron showers. Precisely what I am showing here. And here is the event in its actual occurrence. The light is coming down here being pulsed. And all of a sudden it senses the venturi, which forces the light to accelerate. That's what a venturi does. And as it comes out the other side, it eventually recombines. The black goes around, as I showed you. And this is nothing more than a subatomic nuclear explosion. The black is separated from the white. All right, and I'm going to show you what a nuclear bomb does. It explodes the black from the white. It does exactly the same thing, only it's a controlled explosion outwards. This is what Rod showed just recently. This one here, you see it? The black is coming through. Some of the black came through with the white, and it's pushing the white ahead of it. And the white has to concuss, so it glows. The white shouldn't be big. It should be the same size as that black, or maybe even smaller. The white is not supposed to be real glowy like that. All right. As a matter of fact, here's what the photons look like coming through the air. There's a black and a white and a black and a white. They look the exact same size. Now, what they hit here at the venturi, right over here, that's a whole different ballgame. The white goes, and the black just continues on its little way. And back here is what's called neutrinos. They're not the same value as they keep changing value. See this one up and down, black and white is in the middle. This one black and white is in the middle, but it's sideways. And then you have photons, which is the ones here. There's different particles, and they know this. They call them neutrinos. And they have different energy values because they're different concussive, stacking up on each other, basically, is what it boils down to. And green does the same thing. Green does exactly the same thing, has the neutrinos, same stuff. And then they eventually show up as photons. And then, of course, this was when they came through together. And again, this is light spinning. This is like, and where it's real close and packed together, it glows. It does not want to be next to each other. The white particles do not like to be next to each other. They are not happy and next to each other, so they glow. And that is as much glow as you could possibly get. And back here is fission when the white and the black separated. And the black now wants nothing more than to get back to the white. But it can't get to the center core. This is where we have to harvest the energy. This is what I've been talking about for quite some time. And they claim here you can get giga electron volts. Back here it starts out with mega electron volts. You got millions out here. You got billions over here. That's an increase in energy. And if that increase in energy is correct, which I can't say one way or the other, but I can tell you what, that extreme luminosity is an increase in energy. That's exactly what they say. If you can increase the luminosity, you have increased the energy. If anybody wants to fight with that statement, I will listen. But what I'm talking about right here, we may be able to separate the white from the black. And they say if you can do that, which we did, there's no question we did. Zero question. This started mega electron volts. This should be billions. Giga electron volts. That's what they say. Now, if we can force those electrons, just the white parts, down into the batteries, because we need the white parts. The white parts have to chase back to the black. The black pulls them. The black is a puller. That's why you have black holes. They pull the white around them. Exactly what I showed you the Russians did in space. Right here. And this was in a vacuum chamber in space with charged dust particles. I know the whole story behind this, and it was very interesting. Very, very interesting. All right, this is Atom Central. Watch this. This is a nuclear bomb blast. I've got to run it on extremely low frame rate, so it's 25%. Now watch, see, everything glows. It's just burning. Nothing. That's all the white particles have hit. They're gone. The white particles are ahead of the black. Now comes the black. And there goes the house. Now watch, everything will turn around and come back. See it coming back? Because there's a void back there. You see that? That's the nuclear bomb blast. Only we got it focused from the venturi. There's the black. You see it? The black particles, they're pushing the white. The white, the house is right there. The house burns up and then it blows away from the black. The black's the only thing that's got any weight to it. And it never changes. Exactly what Fermilab says. It never changes size. I agree 100%. This can glow like crazy and it can go down to nothing. And all of these little pulsations are pretty much gravity waves.